through the AP practice problems on the worksheet that we've been working on. We didn't have a chance to finish going over some of it, so I want to make sure I'm able to explain that. I think most people got number 1, but I'll go ahead and kind of go through it. The answer is B. To get that, remember that average velocity is change in distance over change in time. So in other words, the final distance minus the initial distance, or displacement you could say, over the final time minus the initial time. So we need time. If we look, and we also need distance. If we look at this, our first part says 30 miles at an average speed of 60 miles per hour. Well, if you think about it, if you go for 30 miles and you're going 60 miles per hour, then you're actually going for a time of half an hour. Okay, the next part says the next part is going 30 miles at 30 miles per hour. So that must be a total of 1 hour. Let's go back to our equation. Final distance minus final time, well, we need our distance again. We've got a 30-mile distance here and a 30-mile distance here, so that means our final distance was 60 miles away. Minus our initial distance was where we started, was at 0 miles. And then the final time, it took us an hour and a half, so it was an hour and a half later, and we started at 0 hours. But the main thing is you had to find those hours, and without those hours you could not do this problem correctly. So now if we take 60 divided by 1.5 on our calculator, we're going to get the answer of B. Question number 2 asks for us to look at these different diagrams. I want to look at a couple things. One thing is we started to take notes on this, and this piece of it we did finish the notes on, and that is that if we have a velocity time graph, on a velocity time graph, we look at two things. We look at the slope and the area. If we think of slope, it's rise over run, so that's meters per second over run, which is seconds. That is meters per second squared. That is acceleration. So the slope of a velocity time graph is acceleration. The area is length times width, and area is going to be meters per second times seconds. And meters per second times seconds gives us meters, or in other words, displacement. So we need to keep those two things in mind, slope and area. We're always looking at slope and area. So the question on number 2 says, which one is farthest from the origin? That's a displacement question. And so we have to look at the area. We're looking at this area and this area. And so we think of length times width, or base times height. So the area of this one, base times height, is 1 by 1. That's 1 meter. Meter, because over here, and we're going to talk about these cancel out, we get 1 meter. The area on this one, we have, again, base times height, 1 by 1, but this time it's a negative 1. It went down to the negative 1. And so in this case, it is a negative 1 meters. So that displacement is 0. What happened here was this particle went for 1 meter in the positive direction, and then something happened and it went for 1 meter in the negative direction. It's landing right back where it started from. Its displacement is 0. So that's one thing. That actually goes with the question number 4. I'm using it on number 2 because we have to compare number 1 and 2 for, particle A and particle B for question number 2. So this one, if we look at the area of this one, again, we're asking about farthest, that's displacement. Well, honestly, I don't know what this area is. I don't need to, though, because what I do know is that it's positive. It went somewhere. I don't know how far because in geometry, I don't know how to calculate that. I don't know what that curve is, so I don't know, but I do know that it's a positive number. So which particle is farthest? Particle B is farthest. Question number 3, which particle moves with a constant, non-zero acceleration? All right, so we're looking at two things. Well, a couple things. Is there acceleration? That's the non-zero part. And is it constant? Particle A, if we think about, we're looking for acceleration, right? So we're focusing our attention on the acceleration. And since we're focusing our attention on acceleration, we remember that the slope of a vertical time graph is going to give us the acceleration. So let's look. What's the slope of this? What's the slope of this? Each of those has a slope of 0. If the slope is 0, it has no acceleration. It's asking for non-zero. This is 0. So it's not A. So it's not A and B either. Okay, now that one's not it either. I'll tell you that right now. I'll also tell you that on the modern AP test, these questions are really, really old. On the modern AP test, there are only 4 options, not 5. So let's get back to number 3. Constant non-zero acceleration. It's not that one. What about this one? It's non-zero because I'm looking at the slope. It is a non-zero acceleration. Is it constant? It's not. Let me show you a diagram. So this question is asking us, does it have constant acceleration? Does it have non-zero acceleration? If it looked like this, it would be constant acceleration. What we have, though, on the diagram on the previous page was a line like this and a line like this. That is a slope of 0, so that doesn't qualify for the non-zero part. It is constantly 0, but it's not non-zero. On this one, the slope is getting greater and greater and greater. As the slope gets greater and greater and greater, that's not constant. It's not 0, but neither is it constant. And so the answer was neither A or B. That was option D, neither A or B. Because this one is constant, but it's 0. This one's not constant. So neither one of them qualify. And then the last question, which particle is in its initial position at t equals 2 seconds? We went over that a minute ago when we were talking about question B. Let's just go back and think about it. This is t equals 2. I'm going to erase some of this stuff. All right, we're looking at t equals 2. So here we are at t equals 2. Here we are at t equals 2. Which particle is in its initial position? Well, that's what we were saying a minute ago, that this is a positive one and this is a negative one. And so this one has an area of 1 meter. This has an area of negative 1 meter. And so the object has gone forward 1 meter and then backward 1 meter. So it's landing back in the same place. So the one that's in its initial position is option A. Let's just investigate the second option just to see why it's not. It's not at its initial position because it's actually going somewhere. It never turns back. It goes, 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 goes. And so all this area is its distance. I don't know what this area is, but I know it's a positive number. And that's all I need to know for number 4. So if it has a positive area, it has a positive displacement. Okay, next page, number 5. This is one where on the quiz, I will probably take this graph and ask some other questions about this graph. There are a variety of questions I could ask. I could ask some questions about the slope of this graph and what does that imply. I could ask some questions about the area and what does that imply. Remember, the slope of a velocity time graph is meters per second, or in other words, meters per second squared, which is acceleration. The area of a velocity time graph is meters per second times seconds. And that gives me meters, which gives me displacement. So I might look at the area, I might look at the slope. Number 5 is asking us, at what time after t equals 0 does the object again pass through its initial position? Okay, it's a position question. A position question means displacement. So displacement means area. So we need to look at the area of this. Okay, let's look and see what's going on. This object is going in the negative direction. It has a negative slope. That means it's going in the negative direction. And then it turns around. So it starts here, it starts going, and it's going, looks to me like about a half a second that it's going in the negative direction for about a half a second, and then it turns around and its slope becomes positive, but it still has a negative direction. We haven't talked about that yet, but that's what's going on here. So it's going this way, and then something happens, and it turns around, and then as it turns around, it's now turning this way, and then eventually it's going to pass where it started, and the question is, how long does it take for it to pass where it started? It's not a constant velocity. It's accelerating in the negative direction, and it's accelerating in the positive direction. So we haven't talked about that. But what we have talked about is area. So this area tells us how far it has been displaced. Area of a triangle is 1/2 base times height. So that's 1/2 of the base. I'm going to call that 1. 1 second. And the height is -1 meters per second. So I'm going to multiply those together, and I get a -1 times 1/2. That's a -0.5. My seconds cancels with seconds, and I'm left with meters. So in this piece, we went -0.5 a meter in that piece. In order to get back where we started, we need to go a +0.5 meter. So we need to figure out where in this graph can we make up a +0.5 meter. Well, one thing is its area. So whatever area is down here in this little triangle, we want to match with the area over here. Well, I can tell already I've got too much shaded in, right? Like that's way too much. Okay, how about this much? I'm going to say even just visually, that's too much as well. But if you're not sure visually, how about we take the area? If we took the area of this, and I'm going to erase it later because it's not the right answer, but if I took the area of this, I would get 1/2 base 1 second, height 2 meters per second. My seconds and my seconds cancel. 1 times 2 is 2. Half of that is 1 meter. I'm trying to get to 0.5. I've got too much. I need to erase more. So I need to erase more, but I just drew my line at the 2. How much should I erase? Should I erase all of it? No, that doesn't make any sense. So I need to erase some of it. I don't know how much is my sum of it because I don't know what, like now I have to do area equals 1/2 base times height. I don't even know what this is. But what I do know is I need to get it to positive 0.5. If I went to the 2, that was too much. If I go to the 1, that's obviously not enough. It's nothing. So I have to go somewhere in between there. I have to go somewhere in between 1 and 2 seconds. So my answer is C. Number 6, we're skipping. You don't have to do it. If you wanted to do it, this is the equation you would use, and you would plug in your numbers and solve from there. We will get to that next week. Okay, number 7, a distance time graph is what we have, or actually displacement. It says it down here. It says the displacement x. So they used an x up here, but we know that they're saying displacement. We know we measure displacement in meters. Of an object moving along the x-axis is shown above as a function of time, t. So we know time is measured in seconds. The acceleration of this object must be what? Okay, let's take a look at it. We have a distance time graph. The slope of that, rise over run, is meters per second. That's velocity. The area of that would be down here, and that would be meters times seconds. That's a meter second. That doesn't have any meaning for us. We don't have a unit of that right now. So that's not helpful. So we don't care about area. What we do care about is slope. The slope is going to give us the velocity. I don't know what the numbers are because they didn't put any numbers. But if I look at this slope, I can tell a couple of things about it. It is positive because it's going up, and it's constant because it's a straight line. It's a sloped line, but it's a straight sloped line. There's no bumps in it, there's no curves in it, it's constant. So it is a positive constant slope. What's the definition of acceleration? Acceleration is change in velocity over change in time. We just said this wasn't changing. Remember that slope is velocity. The velocity is constant. It is not changing. If it is not changing, there is no acceleration. There's no acceleration. So the acceleration of this object must be 0. All right, hope that helps. We'll have this quiz over this material next week.